I will share this link. Okay. Now you have all the data nodes will be sharing. See, few people are very interested to learn. Those who are feeling boring can go out. Not a problem. Okay. No issues. Can you please go? I can teach for 5 to 10 members who are very interested. Okay. Now you see all the data nodes will be sharing the heartbeat signals to name node only. So name node will be having all the metadata information, right? Now say for example 192 MB. How many blocks? Block 1, block 2, block 3. What's the replication? 3. Say for example block 1 is stored here. Do the same block stores here? No, right? It may store somewhere here, somewhere here. Block 2, block 2, and then block 2. So block 3, block 3, block 3. This is normally how the blocks are stored in a real-time cluster. Name node will update its metadata information in such a way that block 1 is stored in, tell me, data node 1, data node 2, data node 3. Block 2 is stored in data node 2, data node 3, data node 4. Block 3, data node 3, data node 4, and data node 5. So this metadata information of this data will be stored in name node. Now I have written a program to process this data and submitted a job to the Hadoop cluster. Now who will be taking this request? Job tracker is the processing daemon, right? So this request will be handled by job tracker, right? And this job will be handled by job tracker. Now where do all the metadata information of these blocks are stored? With name node. So whenever job tracker takes the client request, it will check internally with name node. Hey name node, I have received a job to process this data. As the complete metadata is with you, can you please share me the block locations? So once name node provides this block locations, right? Job tracker has to process this job. Now job tracker knows that block 1 is stored in data node 1, 2, and 3. Block 2 is stored in this mission, this mission, this mission. 3. Case 1, only one job is running. Case 1. Let's assume that no other jobs are running and only job tracker is processing, only full resources are available, means 10 map tasks are available, 10 reduce tasks are available. No other job is running except my job. So job tracker will ask this task tracker. There is a task tracker here, right? And there is a block, right? Job tracker schedule the job in such a way that it will look for data proximity, data locality. Data locality means the block and the task that it is processing should be on the same mission. This is because it will use the complete bandwidth. I'm in this class. No matter how I speak slowly, you can hear, right? Suppose if you're there outside the room, I need to shout because you're outside. So within the room, no matter how slowly I discuss, you can hear, right? So we are using this frequency. Likewise, this block is here. This task is available. So using this network bandwidth, the block will be processed very fast. So job tracker will check that data proximity first. Now no jobs are running and I have my map tasks available. I have my block. So job tracker will first tell this task tracker to process this block 1. So here mapper 1 is processing block 1. No need of processing again block 1, right? It's already in process. So task tracker, it will tell this task tracker to process this block 2. it will tell this map task tracker to process this map. Now mapper 1 is processing here block 1. In this mission, one mapper is processing block 2, and in this mission, one mapper is processing block 3. The task trackers will be sending periodic updates like 10% completed, 20% completed, right? To whom? To job trackers only they will share, right? So these missions will be sharing that how much amount of job is doing. Here B2, B2, B3, no, job tracker is not asking these task trackers to process, because this we are assuming that everything is running fine. All mappers are available, all blocks are available, and all map tasks are running successfully. But in real-time production cluster, you will not see this scenario, right? There will be multiple jobs running, means using the Hadoop cluster. Say, for example, there are 6-7 jobs running at the same time. For example, there are few jobs submitted already before my submission. Now, job tracker has received these jobs. It is already processing few jobs. Now it has received a new request. So it got the details from name node. Now case 2, let us assume that few jobs are running. When I'm saying few jobs are running means task trackers are busy in processing other jobs, right? Means mappers are busy in processing other jobs, right? So let us assume that now job tracker will check this mission, whether these maps are free or not, because block is free. Now these two mappers are busy in some other job, all of you. Then it will check this mapper. Now here two mappers are there, two blocks are there. Again, these mappers are busy with some other job. Now it will check for this. Here, say for example, one mapper is free, the other mapper is working with some other job. So this mapper will be processing this block 1. Now here, one mapper is there are full mappers busy with other job. Now here it comes, it checks. Here mappers are free, two mappers are free, but there is only one block. This mapper 1 is processing block 1. Here two mappers are there, but there is only one block. B2 is not there. Now how job tracker does is, it will ask any one of the block B2 from this mission which is nearer to this. It will transfer that block to this mission. Okay, and then this mappers, two mappers are there, right? It will now process this job, this block, and this block. That's why the main responsibility of job tracker is scheduling and monitoring. Once this job has been scheduled, it is the responsibility of the job tracker for the entire life cycle management of the job. Means any tasks failing, as it is a distributed environment, sometimes the mappers will be running slowly. Sometimes this mission may goes down. So in that cases, how job tracker handles the request, I'll show you with one example. Okay. Now basically, how to run a job? What is the command? What is the command to run a job? Hadoop space jar. Now basically Hadoop space jar. Now I'm taking 3 mappers, and for each mapper 3 samples are given. Once check this, how the mechanism is going on. Now you see here, I have a job. Now I'm doing this side by side. JPS. Now if you see, it is connecting job. Now you see here child jars. You see, let me keep side by side, then you will understand. Data local map task 3, job finished in 15.861 seconds. So what I do is new tab. Okay, I'll do this side by side. Okay. In this, Control Shift plus 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 SU space hyphen space SD user Hadoop, and in this mission okay. JPS if you see this job CLE are clear. Okay, I'm giving Hadoop 3.3 job, and then if I see here JPS, now you see child jars are there, right? Child jars are nothing but map tasks. If you see child jars, child is there, right? Process IDs. Again, child means map. Now again, child jars are closed means the job is completed. If you see in this mission, once the job is completed, you can see non-terminating decimal, no exact 14 seconds. Now let's go back to your Mozilla Firefox. Total, how many jobs we have submitted? Refresh and check here. It will give you the list of jobs that you have submitted. Job 1, job 2. Click on this job 2. For every job, there will be a job ID, right? User is SD user. Job name, Pi estimator. Okay. And then if you see mapper phase, 100% completed. How many map tasks I have given? 3. Running. Complete. 3 map tasks are completed. Task 0, task 1, task 2. So this is the time taken for each task. Again, go back to job tracker. Now drop down. Click on this job 2. Reducer phase, how many reducers are used? Only one reducer. Even though you have 2 reducers, we have only one reducer. Use. Okay. Now all the job activities here, if you see what is happening during mapper phase, how much amount of these are all known as counters. The same thing you can see on terminal as well. How much amount of data is being used. Slots, milliseconds, time spent by all maps, waiting, everything. You can see this using map output bytes and everything. Map reduce framework, total map content. So these counters are used to check how your job is running, whether it is running slowly or whether it is your job is completed successfully or not. These terminals are not in side by side. Otherwise, you will clearly understand how the process is going on. Right click, new window, SU space, hyphen space SD user, Hadoop. Okay. Now, if you see side by side, I'm giving this job 3, and then if you see here, map 66, map 100%, then reducer phase will start, and then immediately once reducer phase is done, your program is completed, and then the value is submitted to Hadoop cluster. Okay. So what is the main responsibility of job tracker? Even though the tasks are failed, the job will not fail. Until 4 attempts, this job tracker will manage. Okay. So please come. Anyone? Job tracker and task tracker. Line by line and stop at full stops, right? Job tracker and task tracker, very important. Job tracker, task tracker. Yeah, from here.
Job tracker,
Loudly.
job tracker and task tracker are two essential processes involved in map reduce execution.
Loudly, a bit louder. Okay.
Task tracker are two essential processes involved in map reduce execution in MRV1
Version 1, louder, louder.
or Hadoop version 1. Both processes are now deprecated in MRV2 or Hadoop version 2
Deprecated means not in use, right?
and replaced by resource manager, application master and node manager daemons.
Now, what about job tracker? Wait.
The process runs on a separate node and not usually on a data node.
So job tracker will always be running on a master and separate server, right?
Job tracker is an essential daemon for MapReduce execution in MRV1. It is replaced by resource manager or application master in MRV2. Job tracker receives the requests for MapReduce execution from the client. Job tracker talks to the name node to determine the location of the data.
This is what we are discussing, right? Whenever job tracker receives the request, it will talk to the name node to
Find the metadata information, the location where the blocks are located. Yeah.
Job tracker finds the best task tracker nodes to execute tasks based on the data locality.
locality means the task and the block should be running on the same node. Network bandwidth will be utilized.
And the available slots to execute a task on a given node. Job tracker monitors the individual task trackers and the submits back the overall status of the job back to the client.
So as it monitors all the task trackers, how they are submitting the job or how they are processing the job, once it is getting the 100% confirmation of the task trackers, it will submit the overall status of the job to the client. Next.
Job tracker process is critical to the Hadoop cluster in terms of map reduce execution.
So when processing part is there, then only you can get the analysis done. Okay. Then when the node is down and the cluster is down. If job tracker is down, then the processing part is down. Then we go to one example.
When the job tracker is down, HDFS will still be functional, but the map reduce execution cannot be started and the existing map reduce jobs will be halted.
1 second. Now, what does
Yes.
Give JPS, clear and give JPS. Clear, clear, clear. Small letter, small, small. Clear. Page up, page. Signal up, cursor, cursor. Now JPS, remove the clear and JPS. Now let's do one thing. Let me stop the main node. What's the command to stop the main node? Hadoop hyphen daemon.sh. Stop main node. Stop Hadoop hyphen don't use strings. Don't use strings. Hadoop hyphen d capital dot sh space stop space name node. Now you are stopping the name node. Okay, type enter. JPS. Okay. Now your name node is stopped. Name node is the central part of the Hadoop file system. Name node is responsible for storing the data and maintaining the metadata. If name node is down, no problem. Okay. Give me the. Now name node is the central part of the Hadoop file system, right? If name node is down, entire cluster is down, right? Now we have to solve the name node. Now let us try Hadoop exercise method. Hadoop exercise method. Hadoop method.
space forward slash. What does it say? Because as main what is now is unable to read the file system handler. Now let's try the job tag. Let's try the job tag. The first is start upward upward. Now I try for job here. If it is job, how can job tag communicate with neighbor? It is not right. So this job is also next screen. Because job tag is neighbor, right? This makes the connection different. So for a perfect running of a cluster for storage and processing, main node should be up and running, right? Clear. Now let's start the main node again. How do you like the main node access? How do you like the main node access? Start name. Start name. Instead of stop, let me start. Start name. Now you have to start. Now let's do one thing. We should stop after. Sorry, we should stop after. Okay. Those everything is up and running. This paper is down your like suspended mobile. These are another game is running. That was the second paper is up and running. Whether there is no question going on, paper is down. It is also connected to the same question, right? Now everything is connected to the there. Second paper is just monitoring. Now this is running, then there is no people increasing. Modifications are happening. No modifications are now, stop the number. Job tracker. Stop job tracker. Stop job tracker. Remote? No. Okay. Upward arrow. Start name. Start name. Clear. Page of flow. Okay, now JPS. Now you have all the details running there. Next one is JPS. Okay, now Hadoop -d1.sh. Hadoop -d1.sh. D dot space stop job tracker. Now you are starting the job tracker. Job tracking is most important. JPS. Come down, clear and go back to your code. Clear. Now your main node is running. Your processing part is gone. Let's see what happens. Hadoop purpose -ls. Hadoop purpose -ls. Hadoop purpose -ls. Hadoop purpose -ls. Forward slash. Enter. Now you can read the file system. Yeah. Using upward arrow, submit a job. Hadoop job is there. Hadoop job command is there. Enter. Now the job tracker is unable to connect to 543 because job tracker is down. So job tracker down means your job will not run. If may not down means our storage part and processing part will be down. So neighbor function is very important for Hadoop.
Now what is your assignment for today is? What is your assignment for today is Hadoop architecture, that is HDFS architecture. In this HDFS architecture, you have name node and data node. Name node, metadata, information. Where do this name node metadata information will be stored? FS image and edits log. So you need to know about FS image and edits log. Then secondary name node. Secondary name node is also known as checkpoint node. Why? Because it does the checkpointing process. Next, once this is done, Hadoop FS commands, all 1.x commands. Next, job tracker and task tracker. What you do is just go to this Chrome, type practical Hadoop ecosystem PDF. Practical Hadoop ecosystem PDF. Okay. In that, this is very, very important book. Okay. So you can get this book from, or else there is a site called PDF Share. Go to this PDF Share. In this PDF Share plus practical Hadoop ecosystem. Download practical Hadoop ecosystem PDF is there, right? Now download practical Hadoop ecosystem PDF. So download PDF. This is a very, very important book. Okay. So download this book, everybody. Download. It will download in 30 seconds. Once you sit and practice, then only you will get to know all this. Okay, technology and how it is working. Now here, this is very, very important book, and I'll share to Kapil. Otherwise, he will be sending you, or else simply go to Google PDF Share plus Practical Hadoop Ecosystem. Please download this book and start reading the storage part, which covers all the daemons. Let me show you. The more you read, some points I may not be able to tell. The blog will say few more points. The points that I mentioned, the blog will not say, right? So you should have the combination of all the information. Tanvi, what's the problem? Tanvi, what's the problem issue? What's the issue? She's asking what? Now you see here, there is a fundamentals, and in that you have an introduction. Why Apache Hadoop? And you see Hadoop daemons are there, right? In this Hadoop daemons, you can see name node. Hadoop daemons, name node. So what does name node do? Right? And what are its important properties? Secondary name node. If you read this book sincerely, right, you will exactly follow what I am saying and you will have a better understanding. So slowly I will be giving some PDF. This is starting, and also you have, I told you, right, Apache site is there, right? Apache Hadoop plus Hadoop daemons. You can go to the Apache Hadoop site. There is so much information. Okay, Hadoop daemons. Now here you see this is Hadoop daemons, and here you can see what is name node, data node, task tracker. Everything is information is there. Architecture. This is 2.x architecture, 3.x architecture. So just click here, upward arrow. Now here you see HDFS architecture, user guide. These are all very, very important. Now coming back to this book. Coming back to this book. There is a yes. Now secondary name node. What is its use? And you know what the secondary name node does? And then the next one is data nodes, right? What are these properties? How data node communicates with the name node? See, can you please read that? A data node communicates with the name node periodically every 3 seconds by default, heartbeat signal, right? And also it block reports to the name node periodically. In the block reports, a data node reports which block replicas, everything information is there. It has, and if any block replicas are corrupted, the name node also creates block replicas for under replicated blocks and removes block replicas for over replicated blocks. Yesterday I told you, right? Under replicated, over replicated. So you'll be having all this information written very clearly. So if you see what is the name node WI port number 50070, everything information is given in this. So I request everything to have this daemons job tracker. What is job tracker doing? Now you see task job tracker is giving a task to task tracker. It is internally creating a new JVM task instance. So in this, how the job, this is the important questions they will ask you. Can you please explain the job flow in job in 1.x version? The same steps we have discussed, right? Job tracker and task tracker, right? Till this page, please go and complete the steps. So what is your assignment? First thing is HDFS architecture, name node, data node, name node metadata information like FS image and edits log file, secondary name node, checkpoint node, and then Hadoop FS commands from 1.x version, job tracker and task tracker, download, practical, Hadoop, ecosystem, PDF. This is the assignment for you for today. Please go through this, okay, and then complete the assignment for today. Thank you.